This is lesson 5-3 notes over comparing functions. We have no new vocabulary for this lesson, so we're just going to start with what is in blue. It says functions can be represented by tables, graphs, equations, or words. We talked about this in 5-1. You can compare two functions by comparing the rates of change and initial values and then writing function rules in slope-intercept form. So remember, this is slope-intercept form. Okay, y equals mx plus b. Y represents our output, m represents our slope, x represents our input, and b represents our y-intercept. All right, that's not new information, but here's what we are going to change. All right, b, our initial value, is the same as our y-intercept, but we're going to write initial value. Remember that the initial value is the thing that we start with. Right? M, okay, yes, it represents slope, right? But slope is the same as rate of change. So one more time. Okay, output, input. M, our slope, is the same as rate of change. Right? Remember, we write slope as a fraction, rise over run. And rates are also written as a fraction. Okay, b is our y-intercept, also known as the initial value. And this is what we're going to think, this is how we're going to think about them for this lesson and for this chapter really in general. Okay, number 1, we're just going to get started. It says, suppose you want to decide which movie streaming service you should join. Company A charges $1.50 per movie with a startup fee of $5. The cost to stream movies from Company B is shown in the table. Find the initial value. Okay, here's what I'm going to do. I'm going to underline that, and I'm going to put B. So find the initial value and the rate of change. I'm going to put M, okay, of each function. Then determine how much more Company B will cost than Company A if 15 movies are rented in 1 month. So we have multiple steps here. Right? The first says to find the initial value and rate of change of each function. There are 2 functions. Okay, then determine how much more Company B will cost than Company A if 15 movies are rented in 1 month. All right, so we were told in the problem, okay, that the cost to stream movies from Company B is shown in the table. So this is Company B. Okay, and then Company A was in words. All right, so I'm going to go back to the top. I'm going to read it again. Suppose you want to decide which movie streaming service you should join. Company A charges $1.50 per movie and a startup fee of $5. Okay. The cost to stream movies from Company B is shown in the table. Find the initial value and the rate of change of each function. Then determine how much more Company B will cost than Company A if 15 movies are rented in 1 month. All right, I'm going to start with Company B. We actually did this in Module 4. The rate of change is the same as our slope. And the way that we found slope was by kind of doing these little jumps and seeing how our values are changing. So over here, we're going from 2 to 4, which is an increase of 2, and 4 to 6, which is also an increase of 2. Okay, 8 to 12 is an increase of 4, and 12 to 16 is also an increase of 4. So same numbers, so that works. Now remember, okay, that our rate of change is M. Okay, and if I think back to what we did last module, I'm going to write this up here along with rate of change. Let's write rise over run. Also, the change in y over the change in x. All right, so if I come back down to number 1, I'm going to kind of leave it where you can see it. Okay, I put the change in y over the change in x. So I'm going to write it as a fraction because rate of change is the same as slope. Okay, but I'll actually write this down here. We'll do change in y over change in x, and maybe it'll make you see it a little bit better. So I'm going to go back here. The change in y. This is our y value. These are our y values. So over here, this is how our y values are changing. So the 4 goes on top in the numerator. Okay, the change in x goes on bottom. Okay, notice here's our x value. So the way that our x's are changing is by 2. Okay, but 4 over 2 is the same as just 2. So our rate of change is 2. So essentially, the cost goes up $2 for every one movie. What we originally found was that the cost goes up $4 for every 2 movies, but we can simplify. $4 for 2 movies is the same as $2 for 1 movie. So our rate of change, 2 over 1, just simplifies to 2. Okay, and then what we start with, that is B. So I'm going to write IV for the initial value, and I'm going to put B here. Okay, so from here, okay, our initial value, we need to look for the 0 in the x column, but it is not there. However, 2 is really close to 0, so here's what I realize we can do. Okay, to go backwards, okay, if I'm going forwards by 2, okay, well, if I go backwards by 2 would be 0. Okay, remember that when we go backwards, we have to do the opposite. So if we're adding 2 here, we're going to take 2 away here, which means on the other side, going forwards, we're adding 4. So if I want to go backwards, I have to take 4 away. 8 minus 4 is 4. That means for that streaming service, even if you aren't watching any movies, you pay $4 per month regardless. All right, so our initial value is 4. You don't have to put the $sign. Okay, that's fine. I'm going to see. I don't think it tells us to write it in slope-intercept form, does it? It just says find the initial value and rate of change of each function. All right, so that's it for function 1, for the first function, or company B. For company A, okay, we've got 2 numbers here. Right? Our rate of change is the thing that is changing, and our initial value is what we start with. So if you think about it that way, okay, what we start with, literally the word start is right here. The startup fee of $5, okay, that is what we start with. So even if you don't rent any movies, it charges, or it costs $5. So notice the difference. Company A, it costs $5 automatically. Company B, it costs $4 automatically. Okay, but for company B, it's $2 for 1 movie, right? Whereas over here, it's $1.50 per movie. So in this case, if it's $1.50 for 1 movie, then our rate of change is just going to be 1.5. Again, you don't necessarily need the $signs there, okay, unless the problem says to include units or labels. All right, it says, so now I'm done with the first part, finding the initial value and rate of change of each of those functions. It says, then determine how much more company B will cost than company A if 15 movies are rented in 1 month. Ooh, here is where we would maybe want to write the equation, which a lot of you could figure it out without writing the equation, but the equation is so fast to write that it's most of the time very, very worth it. So here, I'm going to write it for company B. I'm going to say company B. Okay, it's just y equals mx plus b, so 2x plus 4. This one over here is going to be y equals 1.5 for m, x plus b. And this is company A. So to compare, all I've got to do, I'm going to kind of move this up here. All right, I'm going to plug in 15 for both of our input values. So for B, it was y equals 2, x plus 4. And for A, it was y equals 1.5, x plus 5. Okay, so for B, oh, we know 2 times 15. 2 times 15 would just be 30. 30 plus 4 would be $34 for 15 movies. Company A, 1.5 times 15 is 22.5, plus 5 is 27.5. All right, the question was determine how much more company B will cost than company A if 15 movies are rented in 1 month. So 34 minus 27.5 equals $6.50. So we're going to say, let's see, company B is $6.50 more than company A, let's say for 15 movies. Okay, and that would be our answer. All right, let's move on to number 2. Number 2 says Angela and Benjamin each have a monthly cell phone bill. Angela's monthly cell phone bill costs 15 cents per minute plus an initial fee of $49. Benjamin's monthly cost is shown in the graph. Find the function's initial values and rates of change, then determine the monthly cost for Angela and Benjamin for 200 minutes. All right, so for Benjamin, rate of change, which is just M, which is slope, okay, and initial value, which is B, where the line crosses the y-axis. All right, and then we also have Angela, which we will come back to Angela. All right, let's start with Benjamin. I always start with the initial value, so if I look at the graph here, I'm going to zoom in a little bit. Okay, looking at the graph, our initial value, where the line crosses the y-axis, is right here at the 60. So the initial value, real simple, 60. That just means that his bill starts at $60 no matter how many minutes he has. Okay, and this is kind of old school. This is how phone bills used to be charged. All right, the slope is how much we're changing. So in this case, we really have to pay attention to these numbers. All right, so my rise, it's going to be rise over run. I'm going from 60, kind of like right here, which is between 70 and 80. Okay, this number right here tells me it's 72. So I'm going from 60 to 72, which is a rise of 12. And then my run is here, and I'm going from the 0 to the 120. So 0 to 120, or you can kind of look down here. 0 to 120 is 120. Right? And 12 over 120 is just 1/10. Okay, or we could even write it as, since it's written as a decimal up here, okay, we can write it as a decimal here. That just means that it's 10 cents per minute. Yeah, I said that correctly. 10 cents per minute. All right, so here's how we're going to write this. Let's go ahead. It says find the function's initial values and rates of change. All right, I'm going to go ahead and put this in slope-intercept form because it's going to be easier for us to compare the functions. So I'm going to do y equals 0.1x, because we don't need that 0, plus 60. Okay, for Angela, let me just there we go. For Angela, it's 0.15 per minute. And I'm reading that up here. It says Angela's monthly cell phone bill is 15 cents per minute plus an initial fee of $49. 49 initial. So that's real simple when we're writing our rate of change, M, and our initial value, B. The initial value is 49. So $49 no matter what, and then 0.15 for 15 cents per minute. All right, so I write this equation, y equals 0.15x plus 49. Now, what did it say to do? So we have to go back. We found the function's initial values and rates of change. Then determine the monthly cost for Angela and Benjamin for 200 minutes. All right, so y equals 0.1 times 200 plus 60. Okay, and y equals 0.15 times 200 plus 49. Two separate. All right, so for both of them, you can plug in the whole thing. 0.1 times 200 plus 60. Your calculator will do those two orders of operations. Okay, we get $80. So for 200 minutes, it costs Benjamin $80. Okay, let's figure out for Angela. For 200 minutes, we just do 0.15 times 200 plus 49. And that equals $79. So it's barely cheaper Okay, we don't have to compare any further. It doesn't say how much more. It just says to determine the monthly cost for both of them for 200 minutes. So that's all we have to do. Angela's is a little bit cheaper, but barely. All right, let's go to SAC. I think we've got 2 more problems to do. Okay, number 2. I don't know how to say this name. We're going to say Aisha. Says Aisha is researching 3 different online book subscription companies. The cost Y, okay, so Y represents the cost of each subscription is a linear function of the number of books downloaded X. So books downloaded is X. The prices for 3 different subscription companies are shown. Aisha plans to download 10 books and wants to spend the lesser amount. From which company should she purchase a subscription? All right, the bookshelf is going to be real easy. All we have to do, it doesn't tell us to find the rate of change or initial value. It just says that she plans to download 10 books and wants to spend the lesser amount. All right, so all I have to do here is plug in 10 for my input and see what the output will be. Because X represents the number of books, so I'm going to plug in 10 for books. All right, so 4.5 times 10 plus 20. Okay, so for this company, 4.5 times 10 is 45, and then 45 plus 20 would just be 65. So $65 for 10 books, right? I have an Audible account. That's really not too terrible. Okay, let's look at We Reads. There are 2 ways that you can do this. The first way, we could go all the way down to 10. Okay, we could go 5, 6, 7, 8, 9, 10. Okay, if the numbers are close enough, that works. We have to figure out, though, what we're going up by each time. So if I want to figure out, make sure that these are all going up by the same thing, remember, I just take the bottom number. So I'm going to take that 41 minus 35.25. Okay, that is 5.75. I was trying to see. Yes, okay, here's the deal. So this is something you'll learn eventually. I actually don't have to find all of them. I know they're all going to be the same because it says it's a linear function. And remember, if it's a linear function, that means it's a straight line. It's going to be a straight line. And slope is always the same for straight lines. All right, so after this initial cost of $18, okay, the cost is going up by $5.75 per book. So if I continue to go up by $5.75 each time. Okay, you can find out ways to do this quicker, but I'm just going to do 41 plus 5.75. Okay, that would be 46.75. So 46.75 plus 5.75 again. And that would be 52.5. Okay, plus 5.75 again. You could also have figured out how many jumps you were making and then multiplied by 575 to get to your answer. Okay, 58.25 plus 5.75 is 64 for 8 books plus 5.75. If I do it this way, I really have to hope that I don't make any mistakes, because if I made one simple calculator mistake, this entire thing could be wrong. All right, depending on what the mistake is. So this way, I got 75.5. Here's the other way that you could have done it. You could have written an equation, and this would be pretty quick as well. So when x is 0, okay, y is 18. So if I set this up in slope-intercept form, okay, my slope I determined is 5.75. Okay, and I know it's 5.75. I didn't do this side, all right, but I knew that that was only 1. So I knew that it was going to be 5.75 over 1, which is the same as just 5.75. But always check both. Okay, I should have shown you that from the get-go. But always check both sides. Rise over run. Okay, I'm going to keep going, though, from where I was. Okay, and then I look for the 0 in the x column. Right, 18 is what we would start with. That would be our initial value. So then all I have to do is plug in 10 for x. 5.75 times 10 plus that initial 18 equals $75.50, which I thought was faster than the way that I did it first. But either way works. All right, so this one, no matter how you want to write it, you could just put like 75.50 0.5 down here. Okay, or you could put y equals 75.5 down there. Okay, that would work either way. All right, let's look at the next one, the graph. Okay, this is bookworm. So the graph doesn't go to 10, so I would definitely write an equation in slope-intercept form, but it's going to be simple on this one. Okay, the 0 is where that line goes through the y-axis at, so let's see, I want to find rate of change m and initial value b. The initial value is 0. That's real simple because this line goes through the y-axis at the 0. The slope, okay, I've got to find by doing rise over run, so I'm going to go up. I'm going from 0 to 15, so my rise is 15. Okay, and I'm going to go over 2. 1, 2. Over 2. So really my rate of change, another way I could write that would be 7.5. Right, so I'm going to write this. This is super simple in slope-intercept form. Y equals mx plus b. It's going to be y equals 7.5x plus 0. But remember, we don't have to write the plus 0. Okay, so I'm going to get rid of that. And then I'm going to plug in a 10 for x. Okay, 7.5 times 10 is 75. So now I'm going to go back to my original question. The original question was, Aisha plans to download 10 books and wants to spend the lesser amount. From which company should she purchase a subscription? Okay, for the bookshelf, $65 for 10 books. WeReads was $75.50 for 10 books. And then the Bookworm was $75 for 10 books. So the bookshelf is the correct answer because she'd spend the least amount of money. And we don't want to spend more money than we have to. Okay, let's look at number 4, last one. Number 4 says Andrea is researching cell phone plans to determine which is the least expensive. The cost y of each plan is a linear function of the number of months x that she has the plan. The prices for 3 different plans are shown. Andrea expects to stay on the plan for 18 months and wants to spend the lesser amount. Which plan should she choose? Okay, so 18 months. We know that x represents months, that's our input value, and that y represents cost. All right, so we're going to do on this problem the exact same thing we did on that last one. Okay, the first one, plan A, super easy. Y equals 50 times, what did it say, 18 months? So 18 for x and plus 50. Okay, so 50 times 18 plus 50 is $950. That's a lot of money. Okay, let's look at our next one. All right, because the number of months only goes up to 3, and we want 18, I would absolutely not go all the way down to 18. It would be easier if you just set this up and wrote it as an equation. So let's find our slope and our y-intercept. So slope, our rate of change, okay, we're going up by 1 on this side. Okay, and then on this side, we are going up, it looks like 45. 145 minus 100 is 45. And because this is a linear function, all of these numbers, since all of these numbers over here were 1, all of these numbers over here are going to be 45. So our slope, our rate of change, m, equals 45 over 1, but 45 over 1 is just 45. Okay, and then remember for our initial value, b, we just have to find the 0 in the x column, and whatever number is across from it is what we start with. So this is just y equals mx plus b. Y equals 45x plus 100. Okay, but again, I'm going to plug in 18 for x. So y equals 45 times 18 plus 100. Okay, 45 times 18 plus 100 is 910. So this one's a little bit cheaper than that last one. Okay, last one was 950. This one's 910. Let's see what this last one is. All right, again, b is easy. 0. All right, so I'm going to write my rate of change m and initial value b. Okay, and b is 0. Where the line goes through the y-axis. That one's easy. But our slope looks like we're going from 0 to 120. So our rise is 120, and our run is 2. 120 over 2 is just 60 though. Okay, so I'll write this up as an equation, as a function rule, slope-intercept form. Y equals mx plus b, so 60x, and I don't have to write the plus 0. All right, so all I'm going to do is plug in my 18 here, and 18 times 60 is 1,080. So not that one. Okay, looks like this time I've got 1,080, 910, 950. She wanted to spend the lesser amount, and it asked which plan should she choose. We're going to say cell phone plan B. We'll just say plan B. Okay, and that concludes the 5-3 notes.